So to evaluate rational inequalities, what we're going to do is we're going to find critical points on the number line because, this is going to be some polynomial that crosses the x-axis at certain places, and we're just going to evaluate where those y values are greater than or less than 0. So all I'm going to do is I'm going to evaluate what those critical points are, and what I do is I simply set each one of the numerator and denominator equal to 0. So can you see if I set 2x minus 1 equal to 0, I'm going to get x equals a half, positive 1/2. And down on the bottom, I can factor that out, right? So I'm going to get x minus 3 and x plus 3. So I'm going to get x equals positive and negative 3. Okay, so these are going to be my critical points right here. And all I'm going to do is I'm going to just put those on the number line. I'm going to come down here on my number line. I'm going to have 1/2, positive 3, and negative 3. So now what I have is I have 4 sections of my graph, and there's no easier way to doing this other than plugging and chugging. So I am going to randomly pick a point in each section of that graph. It can be any value you want, and then plug it into the original equation and see whether or not it satisfies the equation or not. So let's go ahead and do that. I'm going to get rid of some of this information up here. Let me put these numbers back on here. So I had negative 3, that was positive 1/2 and positive 3. So I'm going to pick, if I pick negative 4, for example, I'm going to get negative 9 on the top over positive 7. So that definitely is less than 0. It's a negative number. It's less than 0. So this section works. So I'm going to basically just highlight that section of the graph. If I pick 0 in this section right here, 0 is between positive 1/2 and negative 3. So if I pick 0, I'm going to end up getting negative 1 over negative 9, which is positive. So if I have a positive number, that does not satisfy it. Okay. Now we can pick a number in this next section. So I can pick between 1/2 and 3. I'll pick 1. And again, you can pick any number you like. So if I pick 1, I'm going to get positive 1 over negative 8, and that is a negative number, so that satisfies my graph. So I'm going to highlight that part of the graph. And then in the last section, a number greater than 3, I'm just going to pick 4. So if I pick positive 4, I'm going to end up getting 7 over 7, which is positive 1, which is clearly not less than 0. So my solution set would be listed, or the answer to this problem would be negative infinity to negative 3. And I'm going to put a square bracket because it's less than or less than or equal to. If it's equal to, it has to have a square bracket. And infinity always has a soft bracket. And then I'm also going to highlight this section between 1/2 and 3, and both of those are going to be square brackets. So I'm going to have positive 1/2, comma, positive 3. And this is my final answer right here. Okay, so now let's do an inequality. So that's kind of easy when you have an inequality that is set less than or equal to 0. Again, you just set your numerator equal to 0 to find the points on the top. You set your denominator equal to 0 and you find your critical points for the denominator. You plot them on a number line, and then you evaluate a point in each section of the graph. Unlike parabolas, there's really no particular pattern. Oh, let me cross that off. There's no particular pattern to these graphs. You cannot assume that, if it includes this section, it won't include the next, and it does this one. Sometimes all of the sections can be highlighted. Sometimes, perhaps the first 2 sections will be highlighted and not the last 2. There's really no pattern to it, and there's no shortcut than testing a point in every single section. Okay, so now what do we do if our graph is not less than or equal to 0? Let's say that I put a 4 in here. So I'll do that on the next slide. So if we have a rational expression that is not less than or equal to 0, so if it is set to some other number besides 0, we're going to have to move the 2 over, come up with a common denominator, so that we can get one single fraction less than or equal to 0, because that's the only way to get those critical points. So as a refresher, what we're going to do is I'm going to do 3x minus 7 over x squared plus 6x minus 2, and that's going to be less than 0. And then what I can do, I need to come up with, remember this is really 2 over 1, right? So what I have to do is I have to come up with a common denominator. My common denominator is simply x squared plus 6x. So I'm going to multiply this by x squared plus 6x over x squared plus 6x. Okay, and I need to FOIL that out. Don't forget to FOIL. So we're going to get 3x minus 7 minus 2x squared minus 12x. That's all on the top. Do you see how I did that? I just distributed that negative 2 to both of those. And my single common denominator is x squared plus 6x. So I can combine like terms, 2x squared minus 9x minus 7 all over x squared plus 6x. So again, what I'm trying to do is come up with those critical points. So I can factor this. So remember to factor. So we can factor this, and it factors into, this one is negative 2x minus 7 and x plus 1 all over x plus 6. So the critical points for that number line that I'm looking for are going to be, I'm going to list them up here. I'm going to set them equal to 0, each piece, each little factor. So I'm going to set this equal to 0, this equal to 0, this one, and this one, all 4 equal to 0. So I am going to get positive 7 over negative 2, which is negative 3.5. I find decimals easier to put on a number line than fractions. I'm going to get negative 1, I'm going to get 0, and I'm going to get negative 6. So do you see where all 4 of those came from? Sorry. So all 4 of those. And those simply would be put on a number line, and then you would evaluate a point. Now you're going to have 5 sections of the graph, so you're going to have to test 5 separate points. So if I have a number line, you know, I'm going to have negative 6, 0, oh sorry, that's not 0. I got negative 3.5 in there. So negative 3.5, negative 1, and 0. And I'm going to have to evaluate a point in every single section. So I already did that, and if you took the time to do that, you would find that if you want to test it, it's going to be this section in the middle, and the last section. And remember, you cannot guess that there's going to be any particular pattern to this. It very well could have likely been these 2 sections and skip this one and maybe these 2. There's really no pattern to them. It can be very random. Okay?